For each of the following functions, we're going to compare the graph with the parent function of a cubic, so f of x cubed here, and we need to describe the transformations in words or a sketch. So I prefer words just because a sketch doesn't sometimes show it as well if you don't actually see the exact points. So for this one here, because we have an a value, meaning it's not within the actual thing being cubed here, we're going to say that that's a vertical stretch by a factor of 3. The second one here for b, since the 3 is inside the parentheses where it is being cubed, that's where we know that it is a horizontal stretch or compression. And on the inside here, everything is kind of the reverse. So even though it's a number that's greater than 1, we're really going to be saying that it is a horizontal compression. So horizontal compression, and it is by a factor of 1/3, the actual reciprocal of whatever number that we're dealing with there, just because it's like a b value on the inside of the function. So same thing with the last one. This is also a b value. So it's the same idea, except kind of reverse. So it's still a horizontal change, but instead of it being a compression, it is actually a stretch, which I know is backwards, but because it's on the inside, even though it's a fraction, it's really being stretched by a factor of 3. So in these ones here, the b value, or whatever's happening on the inside, is kind of reverse of what you would think, and we take the reciprocal of that to talk about the factor in which it's stretching or compression. So last one here is sometimes when we have f of k of x, it will look like a vertical stretch. For example, with g of x here, it's 3x to the power of 3, looks like it's being vertically stretched. When we talk about the graph, right, when we pinch two things in on the side, right, if we originally have this graph, and we pinch it in, it's going to be skinnier, which would be kind of the same thing as if we pulled the top and the bottom and stretched it out vertically. So a horizontal compression looks a lot like a stretch. And mathematically, the reason that that makes sense is if we expand this, if I have 3x to the power of 3, that's the same thing as 3x times 3x times 3x, which is the same thing as 27x cubed. Now we see I have an a value where we have a vertical stretch by a factor of 27. So a b value can kind of change into an a value if we want it to, and we should see that a horizontal compression can look like a vertical stretch.